Hey everyone, this is part one of your review for your Unit 2, Test 2, which covers everything from congruent triangles to parallel lines to CPCTC and your quadrilaterals. Okay, so this one's kind of a little more based on the triangles, and we'll get into other stuff throughout the week. But look at this one. Which postulate can be used to prove the following triangles congruent? This means that there's 5, side, 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 angle, side, hypotenuse, leg. So you're always looking for a couple things. You're always looking for the reflexive property, the vertical angles, and things like that. So like on number 1, just because it has a right angle does not mean it's hypotenuse leg. You can actually come in here and add, those vertical angles there. Okay, and then if you look, this is now angle, side, angle, and you're done. This is the reflexive property, and if you can see, now this is just side, 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 and then finally another reflexive property, always looking for that. Okay, and you can name it so it kind of helps you out. That's angle, side, angle there. Now, what everyone had a big trouble with on the test was this question: state what additional, you might want to start underlining this stuff when you read the questions, is required to know the triangles congruent for the given reason. So for instance, this wants to be proven, they want you to prove this by angle, side, angle, but all I have is an angle. So I'm going to vary, and this time it doesn't, you can force it to be true. You can make it up. So, what I'm going to go into my diagram and say is, well, I got an angle, I need another side and an angle, so I need that, and I need this angle, because then that would give me angle, side, angle. So what I did was I made UT congruent to UT, and if you want to, call these like angle 1 and 2 so you don't have to get too bogged down in the letters. You can say I made angle 1 congruent to angle 2. For number 5, this one wants side, angle, side. So again, I have an angle, and so I need the sides around this angle. I need this side and these two sides, because then I'd have side, angle, side. So what did I do there? What did I make true? I made XV congruent to XV. And I made KX congruent to WV. And this one you need side, side, side. This is pretty self-explanatory. You would go in, I've got a pair of sides, I need one more pair, so let's do that one to that one, this one to this one, and you can label that one, okay? All right, given that the figure is ABCDE is congruent to POTJR, complete each congruent statement. CB, so if you look over here, CB would correspond with TO. Order does matter, okay? TO. And then angle J, this one's pretty easy. Angle J would be congruent to angle D, okay? Looking at this proof, this one's pretty simple, but be careful. You're proving a piece. That typically means you're going to see CPCTC. The corresponding parts of congruent triangles are congruent. So we got all these givens. They're already labeled on your diagram. AB congruent to DE. And I'm going to just shorten this up for the sake of time. That's given. Angle A congruent to angle D, also given. And AC is congruent to DF, also given. Now, we cannot prove this angle C is congruent to angle F. We have to prove the triangle's congruent first. And if you look, we absolutely can based off our given. This is going to be side, angle, side, side, angle, side. So this is going to work. So you can say triangle, let's call it ABC, is congruent to triangle DEF. By side, angle, side. You already knew this was going to go in the last spot. And so this is now CPCTC. So one of my students likes to remember this as CCC, and then the PT goes in between. But do remember, this is just telling you, when you prove the triangle's congruent, every little piece is congruent. And so since we prove these congruent, these two angles are congruent. Corresponding parts of congruent triangles are congruent. Looking at the back, there's a big thing to look out for here. So let's go ahead and write our givens. We're trying to prove IG is congruent to HJ. So, you know, start with your given. GH parallel to IJ. That's given. And angle IGJ is congruent to angle HJG, also given. All right, so 3. Well, again, we're trying to prove pieces, so let's see what we can do proving the triangle is congruent. Well, I can see right off the bat that I could prove this triangle to this triangle because I first had this reflexive property, GJ congruent to GJ. That's reflexive. Also, because I have parallel lines, this is a big one. I know this angle, call it angle 1, is congruent to this angle because alternate interior angles are congruent, period. Whenever you start seeing parallel lines, and this like a parallelogram, start thinking alternate interior angles are congruent. So I can say angle 1 is congruent to angle 2 because alternate interior angles are congruent of parallel lines, of course. So, does it look like we can prove these two triangles congruent? I've got an angle, I've got a side, I've got another angle. Does that one work? It absolutely does. This is going to be triangle, let's call it HGI, congruent to IJG. And this is going to be by angle side angle. You prove the triangle's congruent, and therefore you prove all of the pieces congruent. So now I can say IG. By the way, you could have written this part from the beginning, is congruent to HJ by CPCTC. All right, 10. One thing you need to be aware of when you have isosceles, two congruent sides, this angle and this angle are the same, period. So therefore, if this is x, this is also x. I know it says y, but you can replace it. So I know x plus 40, in other words, 2x plus 40 equals everything in a triangle adds up to 180. Subtract the 40, 2x equals 140. Divide by 2, x is 70. On this one, it's a little different. This time you got, okay, these are your base angles, 46. That means this angle is 46. So this one is different. So you get 46 plus y equals 180. That's going to be 92 plus y equals 180. Subtract the 92. And y is going to be 108. Oh, I'm sorry. It's going to be 88. My bad. Off by 20. This one trips a lot of people up because you forget that, oh, 3 sides, that's equilateral. That means each angle is 60 degrees. So we're trying to find x. Well, I know that this angle is supposed to be 60. So when it's supposed to be something, you can set it equal to that. 6x equals 60. Divide by 6, and x equals 10. Very simple. Looking at this one, okay, I think we could probably actually do these problems first and then come back to the properties that might help. All right, so UVWX is a parallelogram. All right, so looking at this guy. we know in a parallelogram the consecutive angles are different and they are supplementary. So for this one, it is set up, you add these two together. So if I added 9x plus 6x, I'd get 15x. 15 plus 15 is 30, equals 180. Subtract the 30, 15x equals 150. Divide by 15, ooh, too many ones. Divide by 15, and x is 10. So we know x is 10. So if I want to find angle U, I simply plug 10 in for x. So that would be 9 times 10 plus 50. I want to find angle x.
I know that these two have to be supplementary. Therefore, if this is 105, this would have to be 75, because 75 plus 105 is 180. I think some of the most missed problems will potentially be from this, unless you act now, because people forget that in a rhombus, this is the biggest thing you forget. This angle here is 90 degrees. That means every single one of these angles is 90 degrees. And also, these two, or these really four angles, are cut in half and they're all the same. And then these two right here are all the same. So when you find one of them, you find all of them. Seems simple, but very easily forgotten property. So let's see what we get. Angle 6 is 42. So automatically I know this is 42, this is 42, this is 42. And now use your brain, okay? If you want to find the other angles, look what shape you've got here. So for instance, angle 3. Okay, look what shape I've got. I've got a triangle, therefore all the angles in the triangle add up to 180. So I can say 42 plus 90 plus angle 3 is 180. And I can find angle 3. So I would do 42 plus 90, which is going to give me 132, plus angle 3, let's just call it x. Subtract 132, x is going to be 48, and you're done. All the other little angles here are 48. Easily missed, easily forgotten. Angle 3 is 48, angle 4 also 48, angle 5 we found to be 42, BEC, let's probably talking about a big, or let's see, BEC, we know these inside angles in a rhombus are going to be 90. Goodness, my lead keeps breaking. Alright, finally, RECT is a rectangle, so the thing about this one is congruent diagonals. Okay, so we know EG is 2x plus 5. We know RC is 50, so this whole thing is 50. Alright, so let's see if I can do this right. 50. Which means each piece would have to be what? If I know the whole thing is 50, what do we know about the diagonals in parallelogram? That they bisect each other. So if this whole thing is 50, that means each little piece is 25. And in a rectangle, since the diagonals are congruent, all four of these are the same. So if this is 25, what is this supposed to be? Also 25. So when something's supposed to be something, you can set them equal. 2x plus 5 is 25. 2x plus 5 equals 25. Subtract 5. You get 2x equals 20. Divide by 2. X is 10. GC. Let's see. Well, now we already know this, 25. And we know ET. Also, we didn't even have to look at that, is 50. We need to find x. So coming back here, tell me if you can figure out all these properties. So does a square fulfill this? Does a rectangle fulfill this? They won't. You might get doubles on some. You might get all of them on some. So see which ones are true for all of them. And let me know if you have any questions.